Leukemia, a deadly blood cancer that affects the lives of children, adults, and their loved ones around them. Normally, our stem cells mature into healthy blood cells, but in the case of leukemia, these stem cells are damaged and mature into cancerous blood cells instead. To treat leukemia, we can transplant healthy stem cells into a patient to replenish their body with healthy new blood cells. So it turns out that blood, while being the source of the problem, may in fact be the solution in this case. A safe source for these stem cells is from the umbilical cord blood collected after childbirth. Unfortunately, only a small number of stem cells come from a single cord blood unit, only enough to be transplanted into a child. And transplanting low numbers of stem cells into an adult patient runs the risk of failure. To increase adult patient survival, we need access to more stem cells. So how do we do that with the stem cells we already get from the umbilical cord blood? Well, stem cells naturally reside in our bone marrow, where they are exposed to special factors that make them multiply. In the past, we have used these factors to try and multiply stem cells in the lab. Unfortunately, when we tried this, the stem cells matured into blood cells instead, and the factors tend to clump together, making it really hard to use in the lab. Therefore, my research looks into alternative factors that are easy to use in the lab and can increase the number of umbilical cord blood stem cells. I have found 3 proteins, one being ficillin that shows promise to do this. And the stem cells that I made with these 3 proteins still retain their natural ability to mature into blood cells, which is vital since the stem cells that are going to be transplanted into a patient need to replenish that patient's body with healthy new blood cells. My research also looks into finding out how these proteins tell stem cells to make more of themselves, in hopes to find genetic switches we can manipulate to make even more stem cells in a shorter period of time, meaning patients don't have to wait so long for a transplant. Ultimately, the goal is to use these proteins to mass produce enough stem cells to be transplanted into any patient. Not only will this increase the availability of the treatment to adult patients, but it'll also ensure that stem cell transplants are safe, effective, and affordable to the general public, giving hopes to leukemia patients and letting them live long and healthy lives. Thank you.